Hello, my name is Cecil Bowe, and my partner is Rod Shavers, and we are Team Code Element. For this project, Team Code Element will focus on how educational technology can be leveraged to bridge the technological gap by implementing coding programs in low-income communities. Who? This project is a quantitative and qualitative research paper that examines the role educational technology can play in helping to bridge the technological gap in low-income communities. This research focuses on teaching elementary kids to code using Scratch and Tinker. The premise of this project is based on the theory that by encouraging disadvantaged kids to code at an early age, this will spark an interest in STEM-related fields later. Qualitative research will be done using data provided by active programs, the Department of Education, and some independent research. Quantitative research will involve interviews with professionals, observations of students using Scratch and Tinker, and interviews with teachers. Why? Here are some of our key findings. Some of the key reasons for the technological gap in low-income communities are cost/financial constraints, cultural differences, ineffective school systems, ineffective teaching techniques, lack of exposure to technology, environmental issues, lack of awareness, lack of programs, lack of parental support, and lack of training. All of these play a role as to why low-income communities are trailing behind most middle-class or upper-class communities.
How? Project timeline. We have broken down our project into weekly milestones. Overall, our project will take approximately 246 hours of work to complete. This screen may be hard to read, so if you would like to view this timeline in its entirety, it is included in the Team Code Element data repository. The link to that will be shared upon request. We use various methods to collect data. The first method was to conduct participant observations. These observations included study sessions in Dallas County, Texas, and DeKalb County, Georgia, with teens from elementary school to middle school. We also observed programs that are currently implemented today that teach students the basics of programming and logical thinking, if they exist. We also conducted survey studies and in-depth interviews in focus groups with education professionals. We use surveys to collect feedback from the participants. Here we have posted examples of two of the survey questions that were asked with their accompanying results. Overall, the numbers show that most of the participants had no experience working with Scratch or Tinker before. However, all seemed to gain interest in programming after trying out these programs. None of the interviewees that have taught in low income communities were familiar with programs that taught the basics of coding at the elementary level. All interviewees felt that teachers would need adequate training in order to effectively facilitate these types of programs. All interviewees believe that exposure to programming needs to be greatly increased to reach a larger number of students. Key findings. At a high level, these are the challenges that we have discovered. Programs that teach coding are practically non-existent at the elementary level. We have discovered that the kids may have low expectations of themselves, and even unfortunately, some teachers may have low expectations of the kids, which stifles their potential. Lack of resources in the kids' homes can lead to a lack of resources in the school's district's classrooms. There are a few coding programs that a small number of schools are offering. However, these programs all have a low amount of students participating. In order to teach coding effectively, teachers need to have training on current programs and tools.
One of our key findings was that when we looked at the Fulton County school system science courses, computer science was not included in the list of courses required for graduation. In fact, it was only available to advanced placement students. As mentioned earlier, schools in low-income areas are usually budget constrained and focus primarily on milestone testing. In addition, low-income schools rarely have the counts needed to justify teachers in this AP course because low-income students usually have a high mobility rate due to rental issues, and top students leave schools in low-income areas in search of charter or private schools that will offer scholarships and better educational programs. Below is a chart that shows the projected employment opportunity growth rate. Based on the projected percent change in employment in selected occupations in computer science between 2010 and 2020, the highest projected growth rate in computer science will be in software development applications and software systems fields, with a growth rate of 57 and 72% respectively, which both require coding skill sets. Current statistics. Computer science in Silicon Valley is primarily dominated and made up of white males and Asians. The percentage of computer science workers in Silicon Valley that were black or Latinos stood at 1.5 and 4.7% respectively. Although there were a total of 46,000 students in the U.S. that took the AP Computer Science exam in 2015, Hispanics and African Americans made up 8% and 3% of test takers respectively. In 10 states, there were no African American test takers, while there were 8 states where there were no Hispanic test takers. Additionally, passing rates for minorities tend to be lower. Some of our key qualitative data came from our teacher feedback. There were only 2 teachers that were familiar with coding. All the teachers agreed that additional training in STEM was needed. All teachers also agreed that an online training format would be beneficial. All teachers indicated the reason for the online training format would be because time was a mitigating factor. Currently, there's not a certification program for teaching computer science. The teachers that are teaching computer science are usually teaching it out of subject. These teachers feel isolated, and there's lack of support of a professional learning community for these teachers.
In our research, we have found that there are some opportunities to help bridge this educational and technological gap. There are programs that teach coding that are offered at middle school and high school levels, and we believe that this can be matriculated down to the elementary levels. School districts do not have policies in place that restrict their schools from implementing coding programs. Furthermore, districts are encouraging their schools to implement curriculums with a greater emphasis on technology and newer technologies. There are STEM programs currently in place at some schools on all levels that show that the resources are available to implement programs to train in coding such as Tinker and Scratch.
Costs. Cost and budget issues are common issues when dealing with low-income schools. In one case, the Fulton County school system has started an initiative to put tablets in the hands of every student, and this can turn out to be somewhat costly. However, there may be some cheaper options out there, such as the Raspberry Pi Zero, which was recently released on a Linux-based system and has a cost of only $5. Once the Raspberry Pi Zero is connected to a monitor and keyboard, it can function as a lower-end programming device. It is important that a point be made that these devices have to be coupled with a good computer science curriculum and also good teachers. The Israeli model. Israel is arguably the best computer science education program in the world. Israel has a head start in the United States since it started developing its computer science program in the 1990s. Israel is considered the startup nation because it has the highest concentration of startup companies and attracts more venture capital dollars per capita than any other country in the world. Roughly the same number of students take computer science as the ones that take physics in Israel. Students have the option of choosing two computer science paths. There's a general interest in computer science path and a more intense coding base. Computer science teachers in Israel are also required to have a bachelor's in computer science and a certification in computer science before they can teach the students. Through this research, we found that there was one very successful model which was developed by Dr. Moses Williams. Williams is the founder of STEM Prep Project. This organization has been around since 1990, and Dr. Williams identified three key success of this organization, which take away from the Israeli concepts. There's an early start model based on the concept of training the mind the way the Olympic athletes develop their bodies, longitudinal training, a period of 10 years, a multi-institutional approach. Students are training in academia, government research laboratories, private research institutes, and industry internships. The political implications of this issue are not to be understated. President Barack Obama has issued a national challenge to train teachers through the 100K in 10 initiative, which is basically training 100,000 STEM teachers in the next 10 years. There are also two bills which have huge support, the Computer Science Education Act and the Computer Science Education Jobs Act, which both have goals of implementing a computer science curriculum model based on the Israeli school system by creating clearly defined computer science education standards. These acts aim to give grants to states to update their computer science programs and to establish a national commission to evaluate those programs as well.
So, let's go over what we learned. We discovered that there are many issues causing the educational gap in low-income communities. These issues include a lack of parental involvement and awareness of programs that teach coding. Throughout our research and interviews, we learned that many education professionals understand the need for greater exposure to coding at an earlier age for students. On the bright side, opportunities to implement such coding programs are steadily increasing due to school districts wanting a greater emphasis put on this subject matter. There are some short-term and long-term solutions that we believe are quite viable. Implementation of some sort of program that teaches the basics of coding can be started. Increase of parental involvement can also be stressed immediately. Solutions that can help with the long-term sustaining of these efforts is for school districts to add computer science to its schools' curriculums, provide teachers with the training to properly facilitate programs that teach coding, and lobby politicians and school board officials to help address the issues that they have.
This concludes our presentation, and we would like to thank you for your feedback throughout the semester and helping us to do this project. And once again, thank you, and have a great rest of the semester. Goodbye.